Hello everybody, my name is Daniel Doc Sewell, aka The Zealot. I am the CEO and founder of External Security, LLC, and I've been working with Jason, aka Syntax, for the last 4 years. This is my 4th year working with him on the DEADFACE CTF. I usually specialize in puzzles related to programming and reverse engineering. Sometimes I do steganography and crypto and a few others like that. I like to throw some little Easter eggs from Halloween movies and some popular American Halloween culture and just make it fun. And we like to also run storylines through our different challenges. So we'll have like a couple of different mythologies that we have that we relate our puzzles to, and then we also have standalone puzzles. And we try to build our challenges based off of real world experiences we've had with various programming technologies and hacking technologies and things like that. So I've made this video to help you walk through the challenges that I'm going to publish to YouTube after the event is over. So I hope you really enjoyed my challenges. I try to make them a good balance between easy ones and challenging ones. Sometimes a lot of people with experience think my challenging ones are too easy and vice versa. But anyway, we try to get a good balance for everybody, so I hope you found something that you could enjoy. And I hope you picked up on a few of the Easter eggs I sprinkled throughout the story. Anyway, let's get to the challenges, and I'll walk through each one of them, and we'll see, and you can see how you did. Okay, now we're going to look at Sleeping Marble Beauty. It's from the book called Fantastes by George MacDonald. And we're going to decode the Zealot's personal recommendations for what to do in this situation. So we click on Download File, and it downloads it for us. And I'm going to open it up in Notepad++, and we can see we get a bunch of nulls here, but we can see some characters in the middle, and we can just make them out. We could use Notepad++ to convert it, but what's going to be a little bit easier is to use strings -EB. And you can experiment with that a little bit for like, it looks like UTF-16 of either Big Indian or Little Indian. And I never can keep them straight. So we can get rid of these and turn it into ASCII or UTF-8 by using a -EB and just running that on the file. Interestingly, if you open this up and get it on Linux, it'll look like Chinese characters. And if you dump it into Google Translate, it comes up with some funny songs about love and stuff, and it's like it's trying to match up best it can, I think. But anyway, it's really funny because it actually looks like it has some meaning to it, but really that's just the encoding. So it's got this poem here about a guy trying to wake up the sleeping beauty inside of a marble glass stone, and at the end there's a string here, and there's a hint right there that the word sleep, and you can see bro right there. So those would be a couple of hints to you that maybe this is rotated, and the fact you've got parentheses and periods and pound signs and equal signs and ticks and whatever tell you that this encoding is probably rotated, but it also includes other characters. So ROT47 is basically like ROT13, but instead of just text characters, it also includes some symbols as well, right? So if we take that and copy it, I'm going to use CyberChef actually. So there's a couple of different approaches. You can paste, and then you can do ROT47, drag it over, and then you can try different numbers, or you could simply just use the brute force that it has. And then scroll down, you'll see at 62, the flag pops out. Uh-oh, you should have let her sleep, bro. And then, oh, at the end. So this is the flag. Now, how did you know that's what this was? Well, by the fact that you can see the word sleep. That's an English word, so it looks like this might be rotated from uppercase to lowercase. Bro, that may or may be something. We don't know. So I would say a combination of that tells you that this has been rotated, and the fact that you've got more characters than what ROT13 has. You can investigate the other rotates. In fact, I usually keep CyberChef handy, and I go and take a look and see what other encodings they have, and that should lead you in the direction. So that's how you can solve this challenge. So I hope you enjoyed that one, and I hope you enjoyed the poem. The poem is a little on the spooky side, a little melancholy. The story is even better. So if you get a chance to read George MacDonald, I highly recommend it. Fantasties. Okay, see you in the next challenge. So we're taking a look at Syncopated beat, Interloper. And what I have done is I've taken the video clip and I've used the command that I'm going to show down below, ffmpeg on Mac OS X, to strip the audio out in WAV format from the .mov file. And then I loaded the .wav file up here in Audacity. As you play it, when you get to about the 2-minute mark, is where the demon voice starts. So as we click right about there, that's when the demon voice starts. And you can hear it. Sounds pretty scary. So I'm trying to find another spot here. Where the second, there's the second voice. Okay, so anyway, this is pretty easy in Audacity. This is a free program you can download. Just select the demonic voices here in the middle, like that, and then go to the menu, which I don't know if you're going to be able to see this on Mac OS X. I go to Effect. Yeah, it doesn't show it on Mac OS X. It doesn't show the menu. I select Effect, Special, and Reverse. Effect, Special, Reverse. And it flips that around. And now when I play it, it'll play it forward. So we'll take a quick listen to it.
Time is reversible, but the music is not. Go back! Go back! Oh no. What's this?
The governor and I, we were all doing a tour of the library here and talking about the significance of the passage of time.
So somebody else talking about time. So let's go in here and skip ahead over that and get back to where the demon is.
They're always trying to one-up me with their evil plan.
Okay, just pick up about where the other second voice stops.
I want to think about a day in the life of our children.
Now, these people from Litton Labs, they're always trying to one-up me with their evil plans. Just for that, I'm going to give you a hint for the flag. The flag is the name of a band from the early 70s that did a song called Fly Like an Eagle. You know, time keeps on slipping, slipping, slipping into the future song. You know that one? Yeah. So enter the name of the band as the flag, all capital letters and spaces between the words.
Okay, so if you had a little bit of trouble understanding, basically he's saying, I'm sick and tired of these Litton Lab guys always interrupting me with their evil plans. Just to get back at him, I'm going to give you a hint for the flag, which is the name of a band from the early 70s that did the song Fly Like an Eagle. And it has the line, time keeps on slipping, slipping, slipping into the future. Right, so this is all time, you know, referencing time. And the name of the band is Steve Miller Band. So then the demon says, enter the flag, all caps, no spaces. So Steve, the flag is Steve Miller Band. Okay, let's start with Serial Killer 01. This year, America's politicians are weighing in on the important issues, as in which spooky cereal is best. Mr. Robert F. Kennedy Jr. has a favorite spooky cereal. Tear it apart, this binary, and see if you can figure out what it is. Okay, so let's go to CK01. And we have the Linux and Windows versions. It doesn't really matter which one you work with. This is an easy challenge. But let's just start off with running the application and seeing what we get. Okay, this year they're weighing in. Mr. Kennedy, what's his favorite cereal? I don't know. Count Chocula. Access is denied. Okay, so it's looking for a password, which may or may not be a cereal, and then it'll give us a flag related to the cereal. All right, so let's start off doing something easy here. I'm going to pop over to Windows Subsystem for Linux, and I'm going to run strings on this binary. And we'll see what we get. We get a bunch of garbage strings. We get a big long string here, which looks like this could be maybe the hex value of an encrypted flag. Maybe. We see flag inoculated, so that's a message. And we didn't see that when we ran the program. We saw access is denied. So this is probably the message you get when you get the right one. And we see another message here. Conspiracy theory access granted, Mr. Kennedy. Here's your booster shot for today. Have a nice breakfast, sir. Okay, so these are probably our positive messages, and access denied is our negative. We see something right here that looks like a string formatter. This could be something useful right here, as could this right here. But we see this other string in here, uber real, oppo real, which looks like it might be useful. Let's just kind of spin through the rest of this application here. A bunch of typical stuff you see in a program compiled by Visual Studio. Let's focus on the uber real string here, obo real. So that looks really interesting. OBBO. Maybe the first thing that should come to your mind, especially on an easy challenge, is let's go to Cyber Chef, and let's just give magic a whirl. See if magic can figure anything out. We'll turn it on extensive, and we'll put in oberreal. See if it comes back with anything for us. XOR, possible languages. Scrolling through here, we don't really see anything. I'm kind of shocked that it didn't actually try this first. Tries a lot of XORs from base 64. Tell you what, one of the really easy ones to try is ROT 13. And it's Booberry. So look, the O's and the B's are swapped, and the R's and the E's are swapped. So it's probably, yeah, 13. We could have tried a brute force, and we would have gotten it. But Booberry is, in fact, one of our ghost or monster cereals. So let's do a quick search and see if we can find monster cereal Booberry, just to make sure. So yes, we have a little ghost here, and he has a cereal. So let's try that for our password and see what we get. CK 2024. Actually, let's go back to our Windows. Window. And type in Booberry. The flag, right there. The most famous nephew loves Booberry. And that is Serial Killer 01. Very simple, as I said. Okay, so let's take a quick look at Serial Killer 02. And you can see I've already got it open here in IDA. We'll come back and take a look at that. Let's run the program. Once again, politicians have spooky serials. Vice President Harris. Tear apart this binary, see if you can figure out. Let's try count Chocula. Access denied. So that's our path we get when we don't have the right password. Let's start off by running strings on this binary and see what we get. Aha, we have a couple of very interesting looking strings right there. Those look like they might be hashes. And we can see our access is denied string. That could be useful for something maybe. That's really interesting looking. Sorry, I forgot to give you this. It might have been helpful, but I see you didn't really need it. I wonder. And then secret, here is your yellow school bus pass for today. Have a nice breakfast, ma'am. Flag unburdened. Okay, so that's our happy path right there when we see flag unburdened. So if we pull this up under IDA, what I like about IDA is I really love this graph view. Kind of lets you see the program flow, right? so you can see where your paths are. There are good paths and are bad paths. So let's look at the beginning of the program here. And you really don't need to know a whole lot about reverse engineering to solve this particular challenge, because what we're going to do is we're just going to try to march us to the happy path here. Actually, let's go back to our strings for a second. We'll come back to that in a minute. I wanted to take a quick look at these hash-looking strings right here. So let's run those over to CrackStation and see what we get. And our second one cracked, yellow school bus, and the first one says not found. Okay, so let's take yellow school bus and see if maybe that's our password. Yellow school bus. Nope, that is not the password. Maybe the second one is. Maybe the second hash would be the password. So the one that we cracked was 104. That's yellow school bus. That's not the password. So perhaps that's being used for something else. But what about this one here? So we have that string. What is that useful for? Well, look at this other string right here. This is interesting. And you also noticed it said there might be more than one way to skin this cat. Let's take a look at this. Does this string look familiar to anybody? To me, that looks very much like a Hashcat mask. Okay. So starts with a character, has a number, and then the third field ends in AY, and then or either A or Y, I guess, and then -4 could be OR. So the first one is a character followed by 4, which is either the letter O or R, and it ends in a Y, A and Y, and then there's some other things, there's digits in the middle. Okay. So what we can try to do, in fact, I will just show you, I have this cooking right now. Let's SSH over to my password cracking system. And cd to bin hashcat 6.2.5. Let's type in Byobu, because I already have our session running there. If I hit F7, we should be able to scroll up. And I have passed that hash in. And that hash looked to me like a M0. That'd be a MD5 sum hash. And then I passed in that string that we got along with the hash in a file. So if you choose to do this route, you're going to be cracking, well, on my GPU, I'm getting 14 billion hashes per second. Yeah, MD5, 14 billion. I expected to get a little higher than that, but it might be because of the dictionary type here. 14 billion per second, and it could take up to 90 minutes to crack the password. But apparently this is a correct format string, and this is an MD5 sum hash, so maybe that'll work. We'll let that run, and we'll probably have to come back to it at some point in the video to look at it, because it says we still might have an hour. And so let's go ahead and proceed now with our IDA. All right. So here's where we're outputting our strings. There might be more than one way. Enter the password. The password gets entered. Gets entered right here. So this is, yeah, this gets entered right here with this call as sub. That's probably like scanf or something. And then some things go on here. And like I said, you could try to dig in really deep to try to figure out how all this is working. I like to do things a little bit differently. Oh, check this out right here. What is all this stuff? Interesting. But what I like to do is come down to where the happy path is, and the branch right before that either comes here or goes up here, and put a breakpoint right there. Okay, see if I can catch it. And I will do a run. Okay, password, Cocoa Puffs. And the program runs to completion. It doesn't get there. So we can go up to this one right there and put a breakpoint right there. So you can see with this branch right here, actually, if we look at it, JNZ, and we should have looked at this one first. If we look at it a little bit further where it goes down to this block that says access denied, right? So we know that's our SAD path. So we want to catch right here, and we just do a F9 to run, and we are okay, we're stopped right there, and you can see this blinking line that tells us we are about to take the SAD path. So you could do a couple things here. You could try to patch the binary and rename this instruction to JZ from JNZ. So I'm trying to remember how to do this. There is a way to patch. I think it's from like here. You can. There's a way to come in here and just change. You're already on the instruction. There's a way you could patch the binary so that it always follows through. So if you were to find out this location of this instruction in the binary, you could patch it. I thought it was up here somewhere. In any case, this is going down the SAD path. So what we can do really quickly is we can just put our mouse right there, right click, and say set IP. So we are no longer going down the SAD path, we're going down this path right here. So let's hit F8 a couple of times. And it's going to loop back up, and it's going to end up doing that check again, right? So we can bypass that by just putting our mouse right there, and doing another right click, saying set IP. And if all goes well, we hit F8. Okay, that did go well. And then we hit F8, 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 F8. Here's your yellow school bus pass, flag unburdened. Okay, and so now we can come down this path here and put another breakpoint down here somewhere, right about a place where it says flag unburdened. So let's put a breakpoint right there, or we can just simply say right click and run the cursor. And then we can just F8, F8, F8 all through these instructions. And we can go over to our window. And there you see the flag. Madam Harris eats Frankenberry on yellow school buses, with Q's for eyeballs. And then there's your string right there. And like I said, eventually that will crack the password, which then you could come in here and enter and get through. So that was the reference to more than one way to skin this cat, was you could either crack that password, enter the password, and be dropped in, or you could, walk through the program here and just go down through the happy paths, do a set IP to skip over the evaluation, JNZ for jump not zero, or JZ jump zero, JNB jump not. I forget what JNB stands for. But anyway, you can stop on those instructions, set the next IP, and move down. We're going to have another challenge later that looks almost like this one, except you won't be able to do that trick on that one. That one will require a little bit more finagling, including some memory inspection and stuff, but this one was pretty easy. All it required was to find the right instruction that would send you down the happy path, skip over the comparison function, and then just move down the happy path by doing set IP. Okay, I hope you enjoyed that one. Taking a quick look back at our password cracking. This was for Serial Killer 02, the Harris challenge. There's our password right there. Frankenberry. Sorry, let me select it on the right screen. Frankenberry with a 4 and a 3 for the second E. So if we go back, we can try that real quick and make sure that that works. So that's for Serial Killer 02. When so Frank for can B-R-R-Y. There we go. So that works too. So you can use this with Hashcat to crack the, I believe it was an MD5 sum hash, and that was that you get from just doing a strings on the binary. So anyway, that's an alternative method to solve Serial Killer 02. Let's take a look at Serial Killer 03. I'm doing a preview here because the contest is ongoing and this hasn't been released yet. So anyway, Serial Killer 03, President Biden's favorite spooky cereal. Tear apart the binary, see if you can figure out what it is. So I've got it preloaded here. Clicking on OBS Studio again. I got it preloaded here, so let's shrink down the browser. I got it preloaded in IDA Pro. So once again, we can look at the structure of the program in the graph view. We're getting these prompts, enter the password, and this is going to look a lot like the previous one, the Vice President Harris one. And the main difference is going to be that instead of using the true password hash to decrypt the flag, we're going to use what was entered by the user. So walking down the path to get down to here is not going to work. So we could bypass this check and we could fall down this branch, but it's still not going to work because it's going to be using the password entered by the user to try to decrypt, and you're just going to get garbage out. So what I've done is I've gone here to the place right where the ECX and EDX variables are being loaded up. They're being compared 4 bytes at a time, and it's going in a loop, and if it ever fails, it drops down to the branch over here, access denied. So we want to get down this branch, but we have a problem because we don't have the password hash, the correct password. So we're going to get the wrong one. It's going to fall on this branch. But even if we jump here, whatever the hash is that we entered is going to be used to decrypt the password. So instead of that, what I'm going to do is put a breakpoint right here, right after the ECX register has been loaded. In fact, let me move the breakpoint here down just a couple. So they're right there, right before it does the compare. It's going to have the 2 addresses, right? So let's put the breakpoint right there and let's run it. And let's use ice cream. And if you'd inspected the previous binary and figured out that the hash is MD5 sum, that it's 16 bytes long or whatever, that would give you a little bit of a hint. And then what you can do is you can just go to like an MD5 sum calculator. So let's just use it here. Let's just do ice cream, and let's calculate MD5. So it starts as C9, 69, ends in 90. Okay, so we can see that that's what we have right here with this address. So if I right click and say on this window here and say synchronize with ECX, we get the start of the hash of our password that we entered, which starts right here, C969. And then if we go to EDX, where the other password hash is, the real password hash, so if we do a right click and say synchronize with EDX, we can see that it's just 16 bytes above, right? So what I'm going to do is I'm going to make it fall down this branch with the correct password hash by simply copying it into the, overwriting the memory where the hash of ice cream is. So I can do that by right clicking and saying edit, and I can just start typing EC C8 8B08 F902 5353 E8. I think that's an E8, not an EB. 700697 4B. I'm going with it. 2F 3F DC. So that's 16 bytes. And then we have to right click and say apply changes or hit F2. So now we've updated it so that both of these memory locations that are being compared are going to have the same value in them, which is the hash of the unknown password. And so now if we hit F8, F8, and we jump into the branch that we wanted to, and it's going to do the comparison 4 times because it's 16 bytes. And now we're in the right branch. And then when it goes to the decrypting code here, which if we should find an XOR in here somewhere, somebody might recognize that it's RC4 encryption being used. But we're going to go ahead and go all the way down to where the password is being printed out, and we're just going to put another breakpoint there. Hit F9 and go take a look at our window. And there we have our flag. Obama counts in the shadows. We're missing a curly bracket. I think that's a one-off error with the 0 terminator. So if you enter this without the ending bracket, it'll accept the flag. Or if you add it, it'll accept that one too. So the main trick was to basically, we had a hash of an unknown password being used in the RC4 encryption algorithm to decrypt the flag. So we just copied the one for ice cream. We just copied the correct one over the top of that one. So we went down the right branch and we had the correct password to decrypt the flag. Hope you enjoyed that one. Okay, let's take a quick look at Serial Killer 04. There's a disclaimer about antivirus warnings. From what I've seen, it doesn't actually do that, but that was just a warning because some things might trigger on a couple of functions that are getting called inside. All right, so the challenge is Dr. Geschichter of Lytton Labs is working on a new way to influence young children to do his evil bidding using monster cereals to do it, putting the trigger words on the cereal boxes. So while the kids are reading them, they'll get into a hypersuggestive state using NLP and subliminal seduction. He's going to program them to carry out his nefarious plans. But turns out he's a boomer, and there's a little flaw in his plan because kids don't read cereal boxes anymore. While they're eating cereal, they're looking at iPads. So they're not going to have this problem. Okay, so I've downloaded the file and I have loaded it up in IDA Pro. And so let's go ahead and run it once just to see what it does. So this is Serial Killer 04. So if we do back, got a different keyboard on here. I can't find the / key. Serial Killer. 2 more weeks till Halloween, Halloween, Halloween. 2 more weeks till Halloween, Lytton Labs. From the Halloween 3 movie, in case you don't recognize it. You should be getting an activation code. Access violation occurred. You should have received your activation code from Dr. Geschichter. If you did not get one, but instead got an access error, cry harder. After receiving your activation code, press any key to quit. Okay. So when we come in here, here's our main function. And we see our prompt strings right here. And then we can put a breakpoint right after the call to this printf statement right there. It's going to do a move. It can be to compare, and it's going to be a jump. Okay. And then we're going to end up inside this exception block. So let's go ahead and start debugging. So we hit our key to continue. And I want to get back to my graph mode. I don't know why this keeps jumping out of graph mode. It's kind of irritating. I'm getting ready to try a different thing here. All right, well, let's just do some F8s. F8, jump 0. So we have a couple of moves. Move EAX, and then we're going to call this address EBP var 4. So that came from EAX right here. So if we take a look at what's in EAX right now, we can see it's actually hex code too bad, too bad. So as you might imagine, if we jump there, we're going to get an access violation because that's not a valid address to jump to. So let's go to the next instruction, do a set IP, and we should just be able to F8, and then we're going to try, and once again, we're at this similar code here. I think this is an artifact of the way the exception gets laid out, I think. I'm not 100% certain. But anyway, we get the same code right here, called too bad, too bad. So we're going to jump to the no op right here, and then we're going to F8, and if we hit F9 and go again, we're going to get another exception. Okay, we're going to get another one. In fact, let me just go ahead and do an F9. And in this case, we landed an address DEADFACE. Okay, so that's obviously not what we want. Let's go ahead and stop the program, start it again. Hit any key to continue. Should be getting our activation code. And so let's skip over those bad addresses again, those bad jumps. So right here, move, then this call right here, which is it came from EAX, so that's too bad, too bad. So let's do a set IP, skip over that, do an F8, F8, F8. Okay. So now we're in another piece of code, and we're going to be looking for where that DEADFACE address is. So we're going to just step through. Actually, we're just going to keep stepping through because what we end up seeing here is we're doing this virtual alloc function, which is very common in malware. You allocate memory with virtual alloc, and then you copy things into the memory. And that's what the memcopy is. So it's probably some kind of shell code. And then we do a push, a memset, and then virtual protect, which is going to change it so that it has execute privileges, so that we can actually execute the code that we unpacked from somewhere. We don't know where it came from. We could have dug into it a little bit to see where it came from, but right now we're going to step over some code right here. So move into EDX, move into this address, move here, and we have a call another address again off the stack. Let's see if that is the one we're concerned with. So call that. Let's step into it. F7. Okay. So here we have move a value in the EAX, shift it right, XOR it, and then jump to the resulting address. That looks really suspicious. It says DD 1982. That's really suspicious. Whenever you see a reference to DD, that's really, really suspicious. Okay. So now we got jump EAX. Okay. So there's our jump to the DEADFACE address. Once again, let's skip past it. Set IP. And then what you've actually got here is you've got shell code that was generated. If you look at this FCMOVBE ST, that very commonly is noted for packed code from Metasploit. So I think the Shikata Ganai uses that. So these first instructions here, if you've done enough looking at addresses, it's going to unpack the code into memory and then it's going to execute it, right? So we can try to hit F9 now to continue to see if we get our so-called activation code from Dr. Geschickter, or whether we hit another address that we have to step into and skip over. So I'm just going to spin this, let it go. I'm going to hit F9 and see what happens. Hopefully you had a sound card on the virtual machine you're running this on. If not, hopefully you hit me up and asked, hey, where's my code? And I would have told you, hey, you need a sound card, and or dig into it a little bit further. One of the two, because you could step through and download the binary that gets supposed to get saved to disk, because it executes it. I think it executes. I don't know if it executes it in memory, if it just actually downloads the file. I think it just executes it in memory, as I recall. But anyway, listen carefully, because you're going to hear the flag. What happens is it goes out and hits a URL, downloads the program into memory and runs it. And what the program is it's a C# binary that uses the Windows Speech API to speak out some words that I programmed in. So this is going to be Dr. Geschickter speaking out loud our activation code, which includes the flag. So listen carefully.
This is your MK Ultra handler, Dr. Charles Geschickter of Lytton Labs. The flag is your MK Ultra activation code. Enter the flag as the word flag with enclosing curly braces. Enter each activation code word inside the curly braces in all caps, with spaces separating the following words: sparrow, aggressive, specter, react, bulldozer, candy, deranged, dead face.
That's it. That was your flag. Your flag was those words that he spoke out with the spacing in between. Those are the words of the flag. Okay? With the flag and the curly braces around those words, all caps, spaces separating. So anyway, I hope you had some fun with this one. This one was a bit of a challenge to get working. Like I said, I don't believe it actually downloads the program to disk and leaves it there. I think it just downloads it into memory and runs it. I used a Metasploit payload for, and that payload was obfuscated in memory with some encryption, as I recall. I'd have to go look at the source code. I think it was just a simple XOR, maybe a multi-byte XOR, and you'd probably see it in here if you stepped into it. But it was slightly obfuscated, the code, so we have our two exceptions right there. And then let's go take a look for it here. So I think we might have, like, maybe one of these functions here I think is an RC4 function. If I remember, I'll have to look at the code. But really, you can get by without digging into that, just by, noticing that, hey, we got this virtual alloc going on here. We have the memory protect, and then we have the, the execution of the code by jumping to the address. And then what happens is the first 16 bytes of the first 15 bytes, followed by a no-op of the payload, are actually the code that sets up that jump to the dead face address. So it's XORing shifting a couple values together and doing a couple things to create the word dead face, and then tries to jump to it. So what you could do instead is you could patch the memory and write no-ops over the top of those 15 bytes and then just let it run. Or you can do what I did, is we step in and find out where it's going to jump the dead face, set the IP around it, and then let it fire, and then it'll execute the payload. So those are a couple of options. I'm sure there's others that you could do to work around this, but you don't have to really dig into that Metasploit payload if you don't want to. And that's, like I said, it's kind of complicated, and I haven't really looked into how it does its packing or whatever. But anyway, I hope you enjoyed it. And like I said, if you had any trouble, I hope you contacted me about. It's a little unique. We did say try to run it in a VM if possible. And if you don't have a sound card attached, you might be wondering where your flag is. So hopefully those people contacted me and asked the question. Anyway, thanks for playing. Okay. We're going to do Serial Killer 05. So I've downloaded it. It's a jar file. So we run a jar file with java-jar Serial Killer 05. President Donald Trump has a favorite cereal. It's great, really great. The reason it is so great is because he likes it. That's what makes it really, real, great. Of course, to maintain utmost secrecy, protect the password, blah, blah, blah. Okay. So, I don't know. Let's try Mar-a-Lago. I think it's Mar-a-Lago, but anyway, incorrect password. So there is a program called JD GUI, which can decompile Java code, and that is what we're going to do. We're going to decompile the Serial Killer 05, and we're going to look at the main function. Okay. So we have an encrypted URL here, and what happens is with the password is successful, the decryption is successful, and it starts with HTTPS, downloads an image, calculates the SHA-256, uses that with AES GCM to decrypt the flag. Okay, so we would really like to go after that password. Let's look at the decrypt URL function. That is a simple XOR. Okay, so we don't know what the password length is, but it's a simple XOR. And the key feature of XOR is that it is reversible. Okay, so you can reverse the function. So let's go and do that. Let's get the bytes from the URL, and I should be able to copy those. Copy, put them in CyberChef here, paste, and we'll get rid of MD5, and we'll go from decimal. Okay, so we have our encrypted bytes right there. So then we're going to do XOR. You could try to do a brute force. I don't recommend it. There's a much easier way to do it than brute forcing. So for XOR, we know based off of the code that it's going to decrypt and make sure that it starts with HTTPS. And since XOR is reversible, if we put HTTPS in there, that's going to decrypt what turns out to be the password, or the password that was used to encrypt it. So brute with HTTPS creates these bytes. These bytes with HTTPS will give you the password. So the password is BR00T. And so the easiest thing to do, I mean, you could try to pull out the flag and set up AES GCM decryption and all that stuff. Why bother? Just enter the password, BROOT. And then it gives you the decrypted URL, and then it gives you the decrypted flag. Fruit Brute is the only cereal for Prez Trump. Okay, so the main takeaway from this, that I've run into a few people that have had difficulty with it, is understanding that XOR is a reversible function, right? And you have known plain text right there. So by providing that, you can get the password back and then decrypt. Just run the program with the password. All right, hope you enjoyed that one. Thanks a lot for playing. Okay, let's take a look at one of the serial killer challenges called Image of the Beast. Uh-oh, it seems like Clippy can't catch a break. First he got sent to HR and demoted 2 years ago for smarting off to his software users. And then last year he got pipped again and demoted again for spilling the Lytton Lab passwords. Dr. Geschichter is slick. He'll probably get away anyway. We got a bunch of their secrets. So it seems Dr. Geschichter is now trying to MK Ultra little children by taking control of their minds with cereal boxes. We must stop this madness before Dr. Geschichter gains more power over the children. We think Clippy's ready to help us by giving us information on Rooney's plans. It seems that Lytton Labs is offering a tour of the academy, and that was built last year, to a small number of lucky sweepstakes winners. We need to get one of our people on that tour, and we think we can do that if you can hack the sweepstakes golden ticket generator. head over to Litton Labs lead engineer Karen's GitHub repository. Clippy said he will leave us some information there. Okay, so we got the Karen Rapper's GitHub repo. Here's Karen Rapper, and she has a repo called Litton Lab Sweepstakes. So we'll go take a look at that. And there's some code here. So this golden ticket check.php, which might be interesting. The back, maybe at some point. Got Charlie with a golden ticket. And we got this image called Angry Clippy. Wow, he really looks angry. And then let's take a look at the comment on here. It says, Clippy asked me to add this image. I have no idea why. It just doesn't make any sense. Then again, nothing Clippy says or does makes any sense to me at all. He is so weird. I think they should have just fired him for all the trouble that he caused. Anyway, Clippy, I'll add your stupid image to this code, but you had better not get me into any trouble because of it, or your new name will be Pretzel. Okay. So let's go ahead and grab the Clippy image. Do a save as, and we'll throw that in, let's see, desktop, DEADFACE, RE, image of the beast. And actually it's not RE, it's actually, this one is under Steganography is the category. So we go back and look at the category of the challenge, Steganography. Right there. Okay. All right. So Steganography, one of the first things you want to do is run strings. Okay. Let's do this with more. So it's a JPEG image. Not surprising. So it's going to have a bunch of stuff like that. Okay, so we had some metadata. Let's go back and do that a little more slowly. Okay, a whole bunch of metadata right here. And we've got some information here. I hate my job and I hate Litton Labs. Codename Clippy, disgruntled employee. I just can't cry anymore. MK Ultra weirder stuff, sick of this place. I hate my job and I hate Litton Labs. Okay. So if we, maybe there was some more stuff in there. So let's go back and take a look. And let's look at this XML a little more closely. Now there's some standard URIs that are used for some of the definitions of the tools and other things like that. We can see a tag in here for disgruntled employee. And if we look a little bit more, we see XMP rights, web statement, HTTPS, schnickschnock.littonlabs.org, schnickschnock, whelp.html. Let's click on that and see what that does for us here. Oh, look, we have a direct message to Turbo Tactical, image of the beast. Let's see what Clippy has to say. I'm sure all of you have probably heard by now I got demoted again. Seems Dr. Schichter got really mad after I accidentally exposed all the department's passwords last year. So I got a pip written up on me, and I got warned that this is the last time I will be given dispensation, a bunch of other stuff. He's really mad, and he says, I don't care anymore. There's some dirty secrets. Absolute mess, whatever. So there's some information here about that. And then it says head over to this URL to see if you can find something juicy. And that's going to be actually for another challenge. But we'll go ahead and take a quick peek at it anyway for right now. And this is going to be the one for the upcoming challenge. And this is actually the running the PHP code that we found in the repo. So we'll come back to that in a second. But looking a little bit further down on the schnick-schnock, we have our flag for Clippy isn't disgruntled. He was never gruntled in the first place. So that is our flag for the Image of the Beast challenge. Okay, now let's take a look at the next serial killer 06. So this is 06B, and this is called She's Got Issues. When you're looking at the scoring server, image of the beast will be shown, and then once you solve that one, you'll see She's Got Issues and Juggling Too Many Tasks. So we go to She's Got Issues. So codename Clippy told us that there's a problem with the Litton Labs Golden Ticket Sweepstakes code that we can leverage. Head over to their code repo and see if you can gather some intel on the state of the development team and other clues that might help you hack the sweepstakes website. So let's go back to Karen Rapper's repository here and go into Litton Labs. And if you're familiar with GitHub at all, you know that people can post their code up here, and people can download it and compile it and build it, run it, and use it based on the license and things like that. And then if they have problems with it, they will post what's called an issue, which is basically like, hey, I got a problem, like a bug ticket. And then other people will comment on it and help them figure out what's going on. Let's go take a look, and we have one issue, what the heck, opened by Ilyan Raskolnikov. So this said, Ilyan, kind of a nasty individual, says, Karen, do you even know what you're doing? This code has a huge vulnerability. I can't fully explain it here because the golden ticket is going to get hacked. We need to convene a meeting immediately. We only have a few more days until rollout. I don't see how we can publish this code. Send me a Teams invite and make sure the other engineers and the director are invited. Ilyan. P.S. Nice work. This will most likely be your job. Karen, Ilyan, what is your problem? Why do you always have to be so mean? There's nothing wrong with the code. Have you tapped into the free stash before the sweepstakes have even begun? So meaning the free drugs that are being offered along with the tour. There's no time to have a code review before rollout. The director's with me, okay? So she's pulling rank on him and telling him to shut his pie hole and let the senior developers do their jobs. And, Dr. Geschichter weighs in, the director of Litton Labs. That will be quite enough, Ilyan. The overseers have made it quite clear that nothing is to stop the sweepstakes. Will you be the one brave enough to tell them that their nefarious plans must be put on hold due to your paranoia? Karen Rapper, please proceed as planned. You and Ilyan can nerd out after the sweepstakes is done. And there's our flag. What the director wants, the director gets. And then finally, Ilyan comes back and says, fine, thanks for helping me document you're ignoring my warnings. Mark my words, the site will get hacked, and when it does, it won't be my head that is on the chopping block. And you both know what our overlords do with heads that they've removed. Don't forget poor Alcazan. If you've been doing DEADFACE for a while, you know I like to throw little Easter eggs out there. And this one is from C.S. Lewis Space Trilogy, the third book, called That Hideous Strength. So if you've never read the C.S. Lewis Space Trilogy, I highly recommend it. Anyway, that is She's Got Issues. And thanks for playing. Serial Killer 06C, Juggling Too Many Tasks. Head over to Litton Labs Sweepstakes Golden Code Ticket Checker website. Hack it so that it spills a golden ticket that our agent can use to get on the tour of Litton Labs. Our agent will divert from the tour after gaining access to the building to try to gather hard evidence we can use against Litton Labs to get them shut down for good. Okay, so let's open this up in a new tab. So we saw this a little earlier when we looked at the thing from Clippy. Clippy sent us here. And also we have the source code because we have Karen Rapper's GitHub repo. So let's go back to the repo and take a quick look at the code. So you could, if you did an attack on the website and you saw Clippy's comment about backup files, you could have gotten this a little early. I threw this out here so you'd have an alternate way of getting to it. So if you did you saw Clippy's hint about backup files being left everywhere, you could try to browse to this and download the code and look at it. Otherwise, we'll just go in here and look at the, get a nice little syntax highlighting code here for the PHP. So what we're doing is we're getting to the two parameters from the URL get code A, get code B. There's the message that's displayed if either one of those is blank. Otherwise, we're going to read the contents of var www.secret. We're going to get those contents, and then we're going to concatenate that with str, which was our code A parameter. So the code A string concatenated with the contents of this file right here. And then we take the MD5 of that. And then if the second code, we get that off the URL, b equals hex dec get. We already got that up here. Okay, well, we're getting it again. Actually, interestingly, we have a couple of things. We didn't need to get it again here. That was an oversight. But we do some checks here. The string must be 32 hex digits, and that hex hash of the string concatenated with this secret must start with a number. So the hash that gets generated, this A here, has to start with a number. That's one of the conditions. And the second thing is that each of these has to be a 32 character string. So here's the one, the regular expression that matches. So we're taking the MD5 hash of the string, so the first parameter, code A, and then we're going to run these checks, and if any of these checks trigger, we're going to send a message, sorry Charlie, no golden ticket for you. So the string must be 32 hex digits. The hex hash has to start with a number. So if not match 32 byte hex string, or not match 32 byte hex string for A or the hash or the string or B. And then also finally the hash itself. I have a hard time getting to that last character right there. And that's like really critical. So that should be the hash itself that we took. That should be an A right there. Must start with a number. So if it starts with a letter of A through F, it's gonna fail. So we want the hash to start with a number. Okay. All right. So then, like I said, this is redundant. Don't need that. Okay. Now we're gonna look at the line which is actually causing the problem. This is what Ilian's got his boxers in a wad over right now. Is this line right here? If A equals B. Okay. So the upshot of this is that there is a vulnerability called PHP type juggling. If you Google that, and maybe you've heard of it. So that's a hint for it. So this gives you some idea that PHP has a problem with comparing types. So the TLDR loose comparison with equals equals or not equals is used in place of strict comparison with a triple equals. Triple equals in PHP from version I think 7 on will not only guarantee that the types are the same, but that the values are the same. If you only use equals equals, it'll actually try to coerce the type of one variable to the type of the other, do the comparison, and if it matches, it just matches. Okay, so that's why it's recommended that you use the triple equals instead of the double equals. This is almost like a dangerous deprecated feature. I believe in PHP 8, they've actually made it even harder for this to work, to do this by accident. But in our case right now, what is happening is that the secret code, which is the A, the hash, so A is the MD5 hash of the code plus the string that we sent, is being compared with B, the second code, or code B, right? So the problem is this is subject to a loose comparison. And what that means is when PHP receives these two things, it says, I got to figure out what the types of these are and figure out if there's a comparison that will work. And so it looks at the first one and, looks at the second one, and depending on what you pass, it might interpret this as a number. And the same thing with the first one. It might interpret it as a number instead of a string. And so what's going to happen is if you send all 32 zeros for B, and A stumbles across a hash that starts with a number followed by a character, so like say 0F, it's going to start interpreting it as a number as far as it can, starting from the left-hand side, so 0F. So it says, oh, 0F, that's a 0. I'm going to drop the rest of the string and make this value a 0, okay? And then it's going to compare that to the 32 zeros you sent in for B and go, well, that's a 0. I've got a match, right? Alternatively, if you have a 0E1, what you end up with is that gets interpreted as a scientific notation, and 0 to any power is 0, so you'll get a match. So all you have to do is for code A, send in a random 32-bit hex string and send in for B 32 zeros. Okay? And to demonstrate this, I can show you, I have written a Python script to do this. So here it is. It's quite simple. So using requests and random, we generate a 32 character long hex string for our random value for code A. We send in for code B 32 zeros, and we look for sorry Charlie, not in the response. We print out the response text that came back. So by doing Python 3 guess.py, that's going to start testing values, random values, and it doesn't matter what they are really. We don't have to know what the secret string is on the far side. We don't care. All we're doing is just generating random strings that look like an MD5 hash until we stumble across one that gets interpreted as a 0. And that will match the second code that we sent for code B. And then when we do that, we get our flag. That's what you get for juggling too many PHP tasks. And then I got a golden ticket. Na 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 na. Okay, Charlie the Chocolate Factory. Willy Wonka and the Chocolate Factory from the early 70s with I'm drawing a blank. Gene Wilder as Willy Wonka. I've never seen the Johnny Depp version. I don't plan on watching it. But the Willy Wonka one is absolute classic. It was on every year when I was a kid, so I have a fondness in my heart for that. So anyway. There's your flag for serial killer juggling too many tasks, and I hope you enjoyed that one. Thanks for playing. Let us now turn our attention to a poem, The Silver Swan. The silver swan who, living, had no note, when death approached, unlocked her silent throat. Leaning her breast against the reedy shore, thus sang her first and last, and sang no more. Farewell, old joys, O death, come close mine eyes. More geese than swans now live, more fools than wise. So it says, download and examine the files below. Do the to-dos, TMTOWTDI, Tim Twody, or there's more than one way to do it, which is the anthem of the Perl programmers. So I have downloaded the program, which is the first part of it is the poem, and then it's going to do some stuff, and it's going to say to do. It's going to give you the to-dos to do, and you're going to come in here and replace where it says code goes here. Okay. So before we do that, let's just take a quick look. You can see we're still trying to do our password crack there. Let's do a strings, or let's do a hex dump on silverswan.enc less. Okay. What if we do cat silverswan.inc A lot of fizz buzz going on. Not a lot useful there. So let's go back, turn our attention back to the poem, to the program rather. All right, so to do number 1, define ROL, taking an 8 character, 8-bit number, and a number of bits to rotate 0 through 8 and return the 8-bit number rotated to the left by that many bits. So you got the number and the number of rotations to the left. Okay, so what you can do here is you can do something like this. So this is the bitwise operator for the first parameter number. We're going to rotate it by the number of rotations to the, or actually we're going to shift it to the left, which means some bits are going to drop off the end of it. And we're going to do an AND with FF, which is going to make sure only the last 8 bits remain. And then we're going to OR that with the number shifted to the right, 8 minus rotation bits. So what does that do? So basically what that does is it takes, so let's say the rotation was 5, okay? So if we shift to the left 5 bits, okay? All right, so you're going to do exactly the opposite with the other one. And so we can do something along the lines of this. So we're going to do a rotate right. Now you notice we're doing an AND right here with 0FF. I'm not sure if that's strictly necessary or not, but we could have probably done the same thing up here. If it shifts to the left, it's going to shift zeros in on the left-hand side. That's why it wasn't required up here. Okay, so now we have our rotate left and rotate right functions. And now what we want to do is we want to split the poem into tokens by spaces, putting each word into the tokens array. So I don't know if any of you have had the pleasure of writing code in Perl in production. Perl is sometimes called a write once language, or write once, read never, warn. So yeah, it's kind of funny. You write it, it's very difficult to go back and read it sometimes. All right, so the split function will split it by spaces. The poem, the string of the poem, which is up here. This is called a here document. And so this whole thing is part of this one long string called poem. And so this is going to split it into tokens. All right. All right. And now we have a variable called m, which contains the value Sewell. And this is going to remove the first 2 characters, and it's going to leave the word well. Okay. So now we define 4 variables called my t1, t2, through t3, t4. All right, remove punctuation from the token string. So we can do that with a line that looks like this. So we want to get rid of all the periods, the commas, etc. So we're going to do that like this. So this means the squiggly here means regular expression, and that's what this is right here. And the equals says take token, run this regular expression on it, and then put the value back in token. Okay. So this is going to be selecting pieces of the string that's going to be a for AMHO, which is a password. So it's going to create a password from words that, so for each token in tokens, it's going to remove the punctuation, and then it's going to select words that match each of these regular expressions. So the first one is the word well. And then there'll be something that matches this string, something that matches mighty one, and then F. And I don't recall what it is. We could put a print statement in there when we're all done and see what the password ends up being. So AMHO is the password. AMHO len is how many characters are in it. All right. So the next thing we want to do is declare an empty directory called AMHO bits. And the way we do that in Perl, and this is very confusing, but you actually use parentheses. Like this, my AMHO bits, and that is now an empty dictionary, okay? And then we have this AMHO gulcha. Gulcha means characters, so password characters. Loop through each character in the AMHO string. For each unique character, count the number of lit bits, or how many bits are in that character. And the result will be a dictionary indexed by the unique characters in password, with the value being the number of bits in that ASCII character. For each unique character, count the number of bits. So we're going to let's do the next. It's been a while since I looked at this code. Now you know what I mean when I said right only. Let's look here. Bit. Set bit to 1 if the current bit in AMHO gulcha is lit, 0 if it's not lit. So we can do that with a line that looks like this. So we take the ordinal. Okay, so AMHO gulcha password character is going to take the current character. If this already exists in the dictionary, skip it. Okay, and if it doesn't, AMHO bits, count the number of bits in AMHO gulcha, the password character, and place that value in AMHO bits dictionary as the key. So the unique character from the password goes in the dictionary, and then the number of bits is the value that it points to. So for instance, if the character W is in the password, which is this long string right here made up of the 4 mighty ones and the exclamation point, the number of bits in the character W is going to be the value in that dictionary pointed to by the character W. All right? So now what's going to happen is we have encrypt, which we're not altogether. Okay, so we do have a to-do for the encrypt, just in case you want to play around with it and test it and stuff. So rotate end character by rotate bits to get dec character. And actually, it didn't say which direction. See if the decrypt does. So, okay, rotate bits. Okay. Looks like I found a bug. So I'm going to have to get this fixed. The comments. So to do number 7 and number 8. So number 7. Number 7 is to the left. Okay, rotate the character by rotating bits to the left. And then for decrypting, it is to the right. To the right. I'll make sure this gets published to the server. Okay, so we already wrote the function to do this for us, so all we have to do is call it. So my inc character is going to call the rotate left by the number of bits. And then the other one down here is going to be the other opposite direction, which is going to be to the right. For decryption, it's to the right. Okay, so let's take a look at what's actually going on here. We'll take a look at encrypting. So encrypt each byte of the file, which in this case is the silver swan.txt. When we decrypt, we're doing the enc. So it's just the only thing that's happening is you're rotating each character in the opposite direction for decrypting we did for encrypting. So let's look at decrypting. So we're going to open up the file .enc, which you've downloaded. Each line is 301 characters ending in 0xa. So what we're going to do is we're going to read each line, and then for each split, we're going to get one character, and then we're going to rotate it the number of bits. So what we do is we go back to the dictionary where each character of the password is the index into the dictionary, and the number of bits that it contains is the value. So it'd be a value from 0 to 8. Okay, so we're going to look up that the current character of the password. So we're rotating through the password over and over and over again. So as we're going through each character, we're taking one character of the password. When we hit the end, we go back to the beginning. And we take that character from the password, we look it up in the dictionary, and see how many bits is in this character. That's how many bits we're going to rotate. Okay? All right. And then we just keep doing that. So encrypting is just going to do it the opposite direction. And you're not really testing the encryption, you're testing the decryption. So now that we have this, the silver swan, ideally what should happen, and you should have, which Perl? We do have Perl. If I do Perl, the silver swan.pl, what should happen, now I'm going to make this as wide as I can and see if it works. Okay, so it does, but it's really hard to see. So let's just do the silver swan.out. Okay, and then let's open it up in Notepad++. All right, and let's shrink it way down. Okay, you see the silver swan right there? The ASCII art. And then you got the string right here in the middle that kind of stands out from the ASCII art. Let's copy that. We'll paste it, and then we'll zoom in on it. And the string says, "You cannot say, but I was told by others to do thus, or that virtue was not convenient at the time." And then the flag is, "This will not suffice, remember that." Period. And there's your flag. Okay. So, hope you had fun with this one. I know it's going to be a little rough and brutal because Perl, you can do a lot of bitwise operations in Perl. You can do low-level programming in Perl if you really want to. It's not fun, but Perl was one of the original scripting languages. It goes way back to the late 90s. I was doing Perl programming in 1996. I think it was pulling data from eBay and creating emails with the output of different auctions and stuff. So yeah, it definitely can. It's a very powerful language. It's just really, really difficult sometimes. A lot of people prefer Python. because it's a lot easier to read. You can do some really clever things. Okay, so anyway, I hope you had some fun with that one. Okay, that's it for my challenges. I hope you guys had a good time with DEADFACE CTF this year, 2024. I'd like to thank all of the contributors. We had several more this year that made it life a lot easier for Jason and me, since we had a lot more help with developing challenges. I think we had a record number of challenges this year. And we tried a couple new things like lumping categories based off of the name of the challenge, such as serial killer and hostbusters, and sprinkled some various types in among them. So a lot of hard work went into this, so I congratulate everybody for all the work they've done. I congratulate all the participants for your hard work and dedication and your participation. You make it worthwhile, and we do this to try to help spread our knowledge and also just kind of interact with other hackers around the world. This is a really big deal. We have hundreds of teams and hundreds of individuals participating, and it's really a big deal for us, and we look forward to it every year. So anyway, I hope you enjoyed it, and feel free to leave some comments in my YouTube channel, and let me know what you thought, or if you need some extra explanation on anything, feel free to hit me up. We're also going to be doing a session at the end where we will answer one-on-one questions specifically related to challenges that might have befuddled you. So anyway, I look forward to seeing you around, and thanks again for participating. Bye-bye.